Energy. Now, what mechanical energy is all the potential energy and all the kinetic energy in a single system. Basically, what mechanical energy is the fulfillment of the law of conservation of energy, that energy can't be created or destroyed. So all potential energy plus kinetic energy has to equal all of the energy. Now, where this comes into play is when we start talking about and start mixing and matching the equations. Okay, so we're going to start talking about scenarios where we have a potential energy and then it's released, and then we have a kinetic energy, and we're trying to figure out what the velocity is, or we're trying to figure out other variables. The one thing I want you to keep in mind is that all the equations, so our going back to our kinetic energy equation, R equals 1/2 our mass times our velocity squared. We have our gravitational potential energy due to gravity. That is going to equal our mass times our gravity times our height. And then we have our elastic potential energy, which equals 1/2 r kx squared. All of these equations can be set equal to each other. Okay, and we need to also remember that work equals force times distance. That one comes into play too. Okay, all these equations can be set equal to each other. In that setting equal, it's saying that the mechanical energy, the law of conservation of energy, that energy is not created or destroyed, it's only transferred. So we can take any of these potential energies and it can be transferred into a kinetic energy. We can take these potential energies and it can produce a force times a distance. Okay, and we can set all of these equal to each other, and these really get kind of confusing, but we just have to think about the scenario that we're dealing with and pick out what equation applies to it.